Well, this is a classic example of rock, paper, scissors. So there are two players, player 1 and player 2, and they play X, Y, Z. Player 1 is playing X, Y, Z, and player 2 could play A, B, and C. These are the different payoffs of this game. As you guys could see, this is like a zero-sum game. And you're being asked to find out, is there a pure strategy Nash equilibrium of this game? Definitely no. And I'm not repeating this. I hope that you guys could find it out that yes, there is no pure strategy Nash equilibrium of this game. Now, then the question is that, can you find out a mixed strategy Nash equilibrium of this game? Well, you also cannot eliminate strategies in this game because there is no strictly dominated strategy here. Again, you guys could do this, which we have already done in our earlier recordings. What we are going to do now is that we will find out the mixed strategy Nash equilibrium. Okay, since you cannot ignore any of the strategy, so you have to assign probabilities to each of these strategies. So player 1 plays XYZ with probability P1, with probability P2, and 1 minus P1 minus P2 respectively. And player 2 plays A with probability P1, B with probability, sorry, not P1, P2, it will be Q1, Q2. So it will be Q1, Q2, and 1 minus Q1 minus Q2. So this is going to be the thing. Now, once you do this, then you'll have to find out what are the expected payoffs from playing XYZ for player 1 and from playing A, B, and C for player 2. So what is EX? Whether he will sit here, here, or here, it depends on whether player 2 plays A, B, and C. So EX is going to be 0 into the probability that player 2 will play A, which is Q1, plus minus 1 into the probability that player 2 plays B, which is Q2, into 1 into probability that player 2 plays C, 1 minus Q1 minus Q2. Similarly, EY is gonna be, that is whether he'll sit here, here, or here. It depends on whether player 2 plays A, B, or C respectively. So 1 into probability that player 2 plays A, which is Q1, plus 0 into probability that player 2 plays B, which is Q2, minus 1 into probability that player 2 plays C, which is 1 minus Q1 minus Q2. And similarly EZ. And if you simplify this, this is what you're going to get, which is 1 minus Q1 minus 2Q2, 2Q1 plus Q2 minus 1, and Q2 minus Q1. So what you can do is that you can solve for EX equal to EZ first, and you got this. So which gives you 1 minus 3Q2 equals to 0. So Q2 equals to 1 by 3. And then you can solve EY equals to EZ. And what you're going to get is Q1 equals to 1 by 3. And 1 minus Q1 minus Q2 is definitely going to be 1 by 3 then. Okay. So player 1 is going to randomize his choices between X, Y, and Z with probabilities 1 by 3, 1 by 3, and 1 by 3 respectively. Let us see what will happen to player 2. Now player 2 is going to play either A, B, or C. Now when he plays A, whether he'll get this payoff or this payoff or this payoff, it depends on whether player 1 plays X, Y, and Z. So player 1 is playing X, Y, and Z with probabilities P1, P2, and 1 minus P1 minus P2. So EA is 0, this 0, into probability that player 1 plays X, minus 1 into probability that player 1 plays Y, and 1 into probability that player 1 plays Z, which is 1 minus P1 minus P2. You simplify this, you're going to get 1 minus P1 minus 2P2. EB is going to be 1 into probability that player 1 plays X, 0 into probability that player 1 plays Y, and -1 into probability that player 1 plays Z. Similarly, EC you're going to get P2 minus P1. And he'll be indifferent between A, B and C if all of them are equal simultaneously. So what you can do is that you can put EA equals to EC. And this is what you're going to get. P2 equals to 1 by 3. And EB equals to EC, you'll get P1 equals to 1 by 3. And 1 minus P1 minus P2 is 1 by 3. So the mixed strategy equilibrium for this game is 1 by 3, 1 by 3, 1 by 3 for player 1, and 1 by 3, 1 by 3, and 1 by 3 for player 2.